All right, welcome everybody to the next lesson in our trigonometric section. And this one we're going to talk about graphing trigonometric functions. And that's going to be, at least in this lesson, just going to focus on the sine, the cosine, and the tangent function. And a couple things what we're going to do is we're going to not only just investigate how to graph them, but really kind of like what makes them what's kind of important about their certain characteristics and how we can relate that to what we've learned. So basically, we'll go through, quite a bit of definitions, and then we'll cover multiple examples of just kind of doing a rough sketch. I don't do a very exact sketch when I'm graphing trigonometric functions, and partially that is because, graphing technology is going to be much easier, but it is helpful to, when you see a function, to kind of have a general understanding of what that function is going to look like, as well as what some of the certain characteristics are. So that's what we're going to tackle in here, and if you are not familiar with the trigonometric functions, then this warm-up is going to be a great review of not only evaluating trigonometric functions, but it's also going to help kind of understand where these trigonometric functions what they look like, where these graphs come from. And a lot of times I see there's that disconnect with students in trigonometry being able to evaluate for the trigonometric functions, but not being able to make that connection to the graphs of the trigonometric function. So that's what we're going to do in this warm-up. I did plus or minus, but we're just going to do the positive version. And I wasn't able to get a scale that was perfect enough. So I am going to use, use black here. I'm going to use this, this as, oops, let's zoom in here. Let's try if I can do that very well. I'm going to make this as my XY axis. So I could only get a graph that obviously had those. So, and let's see, let's call this 1. And then, so that would be 1 there. Then therefore this is going to be 0.5. So we'll go down 1, 2, 2. So this would be a negative 0.5, and this would be a 1. So basically what this axis is, we have the y-axis, which I'm going to call that's the output axis, right? And so basically what we can think about this is we can think about this as like f of theta. Like when we plug in a certain theta into our function, we're going to get an output value. And along the x-axis is going to be our theta function. So in the warm-up, it says basically use the unit circle to evaluate the sine function for the following angles and then plot on the xy axis below. So we call it the xy axis. Obviously, in this case, though, we're going to refer to this or think of this as like the theta, f of theta. And then let the angles make up the x-axis along the y-axis. So there you go. So basically what we're looking into graphing is rather than writing this as like y equals sine of x, we're going to use function notation and represent the output value of f of theta is equal to the sine of theta. So theta is going to be our input value, f of theta is going to be our output value. Now, again, to understand like these angles where they lie in the unit circle, let's just do a quick little sketch here of the unit circle and then at least get our 3 important points. So we have our 3 angles. We have pi over 6, pi over 4, and pi over 3. And I'm just going to kind of represent these. We've already discussed these multiple times in my class, so I'm not going to spend too much time as far as like why these, I'm not going to spend any time actually, where these points come from, because that's something we've already discussed. And hopefully that's something that you are familiar with as well. If not, you can just go ahead and look up the previous notes as far as talking about the unit circle, and that will help you out. So this one would be square root of 3 over 2, comma 1/2. Okay, now again, I am just doing the first quadrant because what we talked about in the class is when you're looking at the unit circle, all the other quadrants are the exact same coordinate points, same reference angles. As long as they have whatever they have the same reference angle as this, they're just reflections. It's basically just reflections about here. So I am going to move through this rather quickly, but again, if you need to reference a lot of these, you can kind of see where I am getting these points. And let me actually just write in these angles. So that's going to be pi over 6. This would be pi over 4, and this one would be pi over 3, and let's do this one as pi halves. And then just remember, this is going to be pi. All the way around the circle would be 2 pi, and if you don't go anywhere, that's 0. And remember, this is the unit circle here, so therefore this point is 1, 0. Let's see, this point would be 0, 1. This one is -1, 0. And this one is 0, -1. Okay, so we got all the information we're going to need. Again, if you want to like reference this as I go through this, I'm going to move rather quickly. So basically what this question is asking is when I plug in 0 in for my angle, what is going to be my output? So basically if I have f of 0, so my angle is 0, what is that going to give me? So the sine of 0. And again, the sine of a point on the unit circle is going to be the y-coordinate. So I look at 0 degrees and I look at that coordinate point, and that's 1, 0. So therefore, the point that I'm going to graph is going to be 0, 0. The x-coordinate is 0, and the output value is going to be 0. And then I'll just do one more, just so you guys can kind of see how this is. And then for the rest of them, I'm just going to kind of, plot these in there. So for f of pi over 6, basically, that is my input. So that's going to be pi over 6 is right here. And basically now what I'm going to say is, what is the sine of pi over 6? Well, the sine of pi over 6 is the y-coordinate for that angle, which is 1/2. And as you can see, at 1/2, we're just going to make a nice little dot. Okay. So the next one is pi over 4. And going through the unit circle, I know that's going to be square root of 2 over 2. We don't really have a good decimal approximation, so I provided it. Square root of 2 over 2 is like 0.7. So I'm just going to estimate that to be around here. The next coordinate point is square pi over 3. And the sine of pi over 3 is going to be square root of 3 over 2, which is a decimal approximation of 0.86. So I'll do something right there. And then the next one is, next angle is pi halves. The sine of pi halves is going to be 1. So that's going to be right there. Then we'll go to our next angle here, which is 2 pi over 3. I'll zoom out here a little bit. So at 2 pi over 3, that is going to be still be square root of 3 over 2. And again, I'm basically like looking at the unit circle in my brain. So if you're not following me with these values, remember the sine of any angle is the y-coordinate of that coordinate point on the unit circle. And you can just kind of look at the unit circle as I'm talking about these, if that helps. The next angle is 3 pi over 4. And the sine of 3 pi over 4 is square root of 2 over 2, which is again that 0.7 value. So we'll put that right around there. The next angle here is 5 pi over 6. And square root of 5 pi over 6, that's going to be back to 1/2. So you can kind of see that we kind of went through this range and then we kind of came back down. Now let's go ahead and get to the next angle, which is going to be pi. And the sine of pi is going to be 0. So then the next coordinate point is going to be 7 pi over 6. And at 7 pi over 6, that's going to be in the third quadrant. So now we're going to be dealing with, so basically when I did sine, I basically just covered all the angles in the first and second quadrant. Well, the y-coordinates are always positive. But now we're going for angles that are below the y-axis. So now all my y-coordinates are going to be negative. And again, basically all I'm doing is taking these and then just reflecting them to the third quadrant. So for 7 pi over 6, that's going to give me negative 0.5. At negative 5 pi over 4, that's going to give me negative square root of 2 over 2, which is again going to be that negative 0.7. So I'll just kind of estimate that right there. And then we're at, oops, not a negative. This is still, there you go. The next angle is going to be 4 pi over 3. I hate when that happens. And at 4 pi over 3, that is going to be a negative square root of 2 over 2, which is going to be at my 0.86. So that'll be right around there. And then I have square root of 3 over 2, which is 3 over 2. The y-coordinate there is going to be negative 1. So I'll plot the point there. And then hopefully you kind of see like this pattern. Like over here, I just kind of repeated, went up and then all the way down. And guess what? Now we're just going to do the fourth quadrant. The points are going to be exactly the same. So I'm just going to kind of speed this up here a little bit. So we'll do 5 pi over 3 because I'm starting to recognize some patterns. That's going to be 0.86, right? Where the negative square root of 3 over 2. We have the 7 pi over 4, which is going to be the negative square root of 2 over 2, which is the 0.7. And then I'm going to have a 11 pi over 6, which is going to take me back to, again, negative 1/2. And then last but not least, we have 2 pi, which is going to, again, bring me back to 0. Okay, so now as we look at this graph, we kind of see like this nice little curvature that's going on, right? So I'm just going to use a different color here and just try to do my best sketch. It's not always easiest with this kind of tablet here, but you guys can see that when I go ahead and sketch this, it makes this nice kind of curve. Ah, dang, I knew it was going to happen. That wasn't actually too bad. I like that. So this is what we call our initial period. All right, and we're going to come back to this once we start getting to some more definitions. But basically what I like to do is, have students kind of bring this up so we can just kind of like have some conversations about the characteristics of this sine function, because the characteristic of the sine function is going to help us relate to the other trigonometric functions. So a couple things that we look at here is the continuity. We can see in this initial period that the graph is continuous. There's no discontinuities, right? There are some extremas. You can see that there's a absolute maximum at pi halves and an absolute minimum at 3 pi halves, right? Or a maximum value of 1 and a minimum value of -1. We can see that there are some x and y intercepts. Looks like the x-intercept is here at 0, at pi, at 2 pi. So each intercept looks like it's like a pi away from each other. I'm not seeing any end behavior, and we'll talk about that as well. Actually, we should cover that a little bit later. We do notice that there is changing from increasing, decreasing. There's no constant intervals. You can see from 0 to pi, which I guess I should just write in 0, right? You can see from 0 to pi halves, the graph is increasing. And then from pi halves all the way down to 3 pi halves, the graph is decreasing, even though it kind of has this inflection right here. And then from 3 pi halves over to 2 pi, you can see it's kind of increasing. So that is going to be something that we'll consider and look at again later. And yeah, so again, I kind of already mentioned the quadrants. We look at the y coordinates, or the output value is positive for angles between 0 and pi. And that makes sense to us in terms of finding the values for sine, because the angles between 0 and pi, the y coordinates are always positive. But then when I start dealing with angles between pi and 2 pi, you can see now that the y coordinates are going to be negative. And what I did is the Desmo actually has a great tool that you guys can go and take a look at. Desmos has a great tool that you guys can actually go ahead and take a look at that actually kind of represents exactly what we just did. So obviously you could get the exact same information without doing this, but it's kind of cool. You can see as the point goes around the unit circle, it's basically sketching the coordinate points on the axes. And then that is how we come up with this exact initial period. Now, the cool thing I like about this, though, is it doesn't stop here, right? We can see that we can continue going around the unit circle, right? We can go again and again and again. Now, this slider here stops and it doesn't go negative, but hopefully what you're going to start seeing now is I can actually go in both directions, right? I can go large in 2 pi, but if I was going to start going negative, then I'd start going back and down in that direction. And again, that makes sense because if we start doing negative angles here, our y coordinate is going to be negative. So the graph is going to be going down as we start going negative. So again, we'll expand upon that. Basically, my goal in this one was just to kind of make that connection here for you with understanding what the graph looks like, rather than just always memorizing, trigonometric functions based on the unit circle or for triangles. So hopefully that helps as far as at least introducing you to the trigonometric graphs, at least for this one, the sine function. So now let's kind of get into what are the characteristics of these graphs and, how are they similar to what we've already learned in functions. So let's move on to that next.